Okay, I start. So the first I want to remind you is that we will have the project proposal submission by the end of this week, basically in the midnight is Sunday. And this is a group submission. So basically, each group submit one. But basically, you need to include the following sessions. Page limit 2 pages, so be concise. But you want to talk about the background motivation, the statement of the problem you want to solve, right? And explain why the problem is important and the challenges involved in solving the problem. And then you want to describe your approach and clearly state your deliverables, right? From our presentation this Tuesday, we realized that a lot of groups still have the deliverables too high level, too ambitious, right? So I can imagine that if you want to get a higher score in this assignment, you need to make your deliverables more concrete, more specific, more realistic. Also, the timeline and also how the work will be distributed among group members. So, any questions here? Okay, if not, let's first continue with our project proposal presentation. And I think we group 23, right? Or 24? Group 23, have you presented? Probably yes. Okay. Group 24?
We haven't presented yet.
Yeah, go ahead.
Okay.
Here I have the timer.
I hope my
Yes,
screen
I
is
can see that.
visible. Okay, yeah, sorry about that. Okay, yep. So, yeah, we are doing a study on detecting and mitigating gender bias in NLP systems. So, why is this important? So, preventing AI systems from perpetuating harmful gender stereotypes is essential for creating equitable technology. So, NLP systems are woven into our daily lives as of now, but they frequently reflect and amplify the societal biases that are present, particularly gender bias. Research shows that a lot of LLMs exhibit significant bias in co-reference tasks and can reinforce societal stereotypes in their predictions. And this bias can kind of affect decision-making processes that are critical and affect areas such as businesses, healthcare, etc. So addressing these issues is not just about improving technology, but it also enhances the system's performance by ensuring reliable and fair outcome that users can trust. It also kind of combats propagation of harmful stereotypes that are influential in AI technologies, which helps us prevent the bias of societal biases that are already present. So this through this we plan on promoting ethical AI innovation, which is vital for developing responsible language models that align with our values. This approach not only fosters a more inclusive environment, but also helps build trust in our systems, ensuring that they contribute positively to diverse communities and support social equity. So our background study is based on a pretty seminal paper called Gender Bias in Co-Reference Resolution. So co-reference resolution is the task of identifying and linking, say, certain relationships between expressions and to enhance the understanding of the text. So this study kind of developed the Winnow bias data set, which is a standardized benchmark for measuring gender bias, which filled a critical gap in evaluation methodologies. It also proposes effective data augmentation and embedding debiasing techniques, offering practical solutions to mitigate bias without sacrificing model performance. This work has helped shape the direction of fairness research in NLP by providing both evaluation methodologies and actionable insights. What we plan to do with this project is addressing gender bias in language models. We will develop bias detection frameworks using datasets such as Winnow bias and StereoSet to identify gender stereotypes in LLMs, particularly in occupation and pronoun association. Next, we'll fine-tune publicly available LLMs to detect this bias with greater accuracy. Finally, we'll implement a bias mitigation system, enabling the models to suggest unbiased alternatives for any biased content they flag, ensuring more inclusive and equitable
Okay, so
outputs.
we need to stop here because it's already 3 minutes. Okay, I guess you get my suggestion last time.
Yeah.
Let's move on to the next group. Group 25. Group 25. Anyone here? If no, group 26.
All right, yeah. Just give me one moment.
Yeah, every group you can think about, right? Given the project proposal you need to submit, right? Any part that is not that clear yet. So try to improve over there. Okay, we can see our
All right.
slides. Please go ahead.
Hey guys, so I'm representing Group 26 today. And so our project is, I didn't have a title slide here, but we're going to be working on creating an end-to-end system to query knowledge graphs to answer medical questions about patient data. So sort of the motivation, like I already explained that, right? But so obviously, like LLMs aren't doctors, right? So we need to have a way to augment their knowledge in order to get good outputs. And so, there's been evidence in the literature that using graph representations on these tasks can improve performance. And, the big obstacle is doing all of this while ensuring privacy compliance. And so for previous work, there actually is already a paper out there that went from, a natural language query to a SQL query to a graph query and then extracted an answer. But so the limitations of this paper was that it focused on like a really old version of like this really common data set that's used in medical applications. And so there's a new version of it these days that has more complex data. And so we'd be interested in integrating that. And so that's the name of the paper. And also, like, they didn't do any optimization techniques when they built their knowledge graph, which obviously has issues with scalability. So we'd like to investigate that as well. So remember that, we can't do everything in one semester, though, right? So we're going to be building off of the previous work. So that paper I mentioned already has a full pipeline built. So what we're going to be focusing on improving is sort of the natural language processing side of generating these graph queries, right? Because the previous paper was working on, going from natural language to SQL because there was a QA data set for that. And then they were going from SQL to graph queries, but we want to go directly from natural language to graph queries to sort of improve performance that way. Um, and, we said that we want to talk about, improving the outputs, right, by including domain knowledge. And so we're interested in, having some sort of, that we haven't figured out yet, like an optimized structure that would allow sort of graph RAG, if you guys know what that is, sort of, retrieval augmented generation, but with graphs. Um, so that's one thing we want to work on. And then for performance evaluation, we have sort of two things we want to look at. So first of all, are the knowledge queries correct? Right? Like are the Sparkle or whatever language we end up using, are those asking for the right things from the database? And also like is the answer correct, right? We can verify that independently. And also like what is the runtime complexity, right? So one of the big issues in graphs is that, and I mentioned this in my presentation last week, like they're so hard to scale. So this is something we'd be interested in because, we know that graphs give us better performance, but we just haven't figured out a way yet to make them as efficient as, typical SQL queries. So we're really interested in, making a step towards better scalability. And that's all I have.
Okay, sounds great. Also perfect timing. I think regarding the scalability you mentioned, I think the first step as a course project, you first make the system work, and then you can gradually go with the scalability issue because I think the health data part uh, is still at the early stage. So the the scalability, yes, it will eventually become an important issue, but probably not at the current stage. Okay,
Thank
so
you.
let's move on. Next one, group 27.
Yes, Professor. I'll be sharing my screen. Can you see my screen, Professor?
Yes, I can. Yeah, go ahead.
As I also told in the class, we discussed with you. So we have made some changes upon your suggestions, Professor. So we want to do anomaly detection from cloud. So our project aims to, develop a comprehensive anomaly detection system for cloud servers. Like we have RADs, which are existing. So we want to incorporate those and improve the security and performance which we could do from cloud. We thought of doing it for multiple attacks, but as you suggested, we want to do only focusing on one type of attacks or some two or three types of attacks, such as DDoS or crypto mining. We want to analyze like the patterns which will be there in metrics to identify some unusual behavior. So anomalies occur, some occur due to normal spikes, and some are the true anomalies. We want to distinguish those two because those are mistaken quite frequently in the cloud servers, and we want to also uh, give notification about unnoticed anomalies and threats as well. So some anomalies will not be triggered due to conventional alerts, so we want to trigger those as well by analyzing like server metrics. Uh, and There is a lack of visualization and insights why that attack occurred and what is the visualization of that. So we want to do that as well. Our project deliverables include a functional prototype, which is which has an ML algorithm which detects the cloud anomalies, and our future scope include data collection and real-time pipeline. Uh, we see that that is a lot to do, so we want to include it in the future scope. And for now, we want to create a dashboard which has all the metrics which we analyze from the data set. But after some time, maybe we'll make the dashboard in the Power BI live, which updates quite frequently. And the differentiator which we have from the existing application is we want to provide a risk score, which I think the the applications which are there now doesn't have, which have different factors based on the needs of the user. And we want to use the machine learning algorithm dynamically to adjust the priorities. If they want to have some other attacks which they want to analyze, we want to have that as well. That is a project deliverables. That's it. Thank you, Professor.
Yeah, thank you. So my main suggestion for can you go back to the deliverables?
Yeah, just a second. Yeah, yeah, Professor.
Is that because anomaly detection has been, I mean, studied widely, right? So
Yeah,
you want to, when you say the machine learning models, you want to be more specific, right? And
okay.
also, don't do the wide range of
Yeah,
anomalies,
yeah,
right?
yeah, yeah,
Focus on something that is unique. Also, the
yeah, sure.
data, I mean, it's like a full stack end-to-end solution, but uh, I think it's not that challenging to make the system work, right? But
Yeah, yeah,
it's the challenging part is that how to make the system useful, right?
yeah, yeah,
Given what have already been there, right? That's something you want to think about, right? The novelty or the challenges.
sure,
Okay,
sure.
let's move on to the next one, group 28.
Let me just share my screen real quick.
So group 25, still no one here?
Yeah, Professor, I'm ready to give group number 25.
Okay, so after 28.
Yeah.
Okay, I
So
can see your slides.
you can see it.
Go ahead.
So our project is using a mixture of experts model to detect and classify lung cancer in CT scans. So, um, when you go to the hospital, the doctor thinks you have cancer, they'll use a computed tomography scan. Um, they may not always be able to see the cancer in the scan, in which case other tests are done. But recently, there's been academic strides toward creating computer-aided diagnosis systems to detect specifically lung cancer just from CT scans. And most of the models that we've seen are convolutional neural network models for this detection and classification of cancer. And we believe using a mixture of experts model could be better.
So mixture of experts allow for increased model size without increased computation, and it does this by having a number of experts which will specialize in different subsets of the data, and then gating which ones are going to be used based on the input that you give it. They can also be These experts can then be within the model combined to give better accuracy in comparison or classification rather compared to single more generalized models.
Yes, so our milestones are very clear. First, we want to identify the data set that we will be using. And for that, we have found really good stuff out there on the Cancer Image Archive, which a lot of other papers have been using to detect lung cancer as well. And then we're going to build our model of in Python using various machine learning libraries. Then we will, of course, train and test our model and compare these results with existing CNN model results. And for that, our deliverables are on the next slide.
Just very briefly to cover our deliverables, we're hoping to be able to create a neural network using a mixture of experts architecture that's able to mixture of experts model that's able to classify lung cancer based on CT scans, as well as present statistics including model runtime accuracy and model size compared to other existing models.
And that's all.
Thank you very much.
Okay. Yeah, that's good. So the topic, I mean the lung cancer with CT scan, that is very good. But on the other side, the mix of expert, those ones has been widely studied in the literature, right? So I think meanwhile, if you look to the image processing on computer vision, and I think this one, the AI also did very well, right? Using the CT scan to diagnose some particular cancer. I think generally speaking, they can do better than human now. Yeah,
Well,
so
we've
take
seen,
this into consideration. Yeah, when you
right.
write
I
your
mean,
proposal.
in the papers that we've seen, the CNN models are normally getting like high 80 to low 90% accuracy. And I guess like our goal would just to try and beat that if possible with a mixture of experts model.
Just to
Another
further,
one, go
just to
ahead.
further elaborate, the current models are focused solely on being able to classify whether a CT image actually has,
Mhm.
is an image of someone with cancer. So our goal is actually not only to detect if the image does have cancer, but also able to classify relatively what stage of the cancer it's actually in, which hasn't quite been done yet.
Yeah, but that's very, very challenging. And but of course, if you can do that, it's very influential. Yeah, try to do that. Meanwhile, think about the transformer, right? So I think now people also use the transformer for computer vision, like this image processing tasks. Right. Okay. I just want to remind you that think about all of those and be more realistic in your goals. So it's definitely a valuable project, but
Right.
but
It's
for
ambitious to see if we can beat
yeah,
the
but
stuff
for the
already
cost
out
of
there, but we'll
answer,
see.
yeah,
Yeah, we'll see.
yeah, yeah.
Thank you.
So, okay. Group 25.
Yeah, so I'm presenting. Uh, okay. Good morning, Professor. So we came up with the group presentation topic as automated document classification using hierarchical taxonomy with LLMs. So before diving into our project, let's go through some key points. Where what exactly is document classification? Process of analyzing categories or classes to documents based on their genre or based on their context or anything. So this is document classification. And let's go to taxonomy. Taxonomy, it provides a formal hierarchical structure for data with an organization or domain to be easily retrieved. For suppose, for the given example, electronics, we'll be having a subcategory of mobile phones, and inside that we'll be having Apple and Samsung. So we'll be giving any document and we'll be giving tags based on the document's context. So why do we need this project? So currently in today's scenario, document classification works on fully or supervised learning methods that require huge amount of human annotated data, which is time consuming and costly enough to acquire a huge amount of data. So, but even though we can use LLM to come to generate this human annotated data, but when it comes to hierarchical setting, it performs poorly. Why? Because they are unlikely to use the structured knowledge. They are unlikely to use a structured label space in prompt. Uh, so, for example, in legal document scenarios, where a legal document classification, which completely relies on the context of the example, so each and every aspect it should be considering. So, in such situations, LLMs might perform poorly without considering the exact scenario. So we came up with a scenario with approach where we'll be using hierarchical taxonomy and LLM for enrichmenting the classes. So initially, first we'll be sending our we'll be giving our documents like raw document. Later we'll be pre-processing this document, and we'll be sending these documents to our label taxonomy model, and we'll be extracting the hierarchical structure. Later, these hierarchical structure will be using API calls, and will without any human interaction, we'll be automatically writing the prompt and asking using the LLM's knowledge space. We'll be asking the LLM to generate more classes used on these hierarchical classes, and asking them to generate new classes with considering the whole context. By this, we'll be getting new classes which uses entire knowledge space and other keywords. So by this, it helps us to generate more information. And when it comes to our deliverables, we'll be creating a model using hierarchical taxonomy and LLM, and we'll be retrieving the information from larger documents based on the keywords and generated. And we'll be also comparing the results generated from this model to other technique models using
Okay, you can stop here. I think my suggestion here is that um, you want to be very clear whether you do the supervised learning or unsupervised, right? So where you should get the ground truth. Right?
Yeah.
So and also the current GPT 4.0 probably can also do fairly good in this one. Okay. So now we have finished the project proposal, and now another task for today is we have 4 groups presenting their papers or applications. The first one is group 1, and remember we have the feedback form that you are supposed to submit, supposed to do for each group. Okay, the first one is group 1. Anyone here?
Hello. Yeah.
Yeah.
Professor, we are here.
Yeah, go ahead. So this is group 1. And in Brightspace, you can find the link to do the feedback. Okay.
Shall we start, Professor?
Yeah, you can start.
Okay. Good morning, everyone. We are group number 1, and today we'll be presenting a paper titled Efficiently Training a 7 billion Parameter LLM with 1 million sequence length on 8 GPUs. So this paper basically explores a novel method to overcome one of the biggest challenges in training LLMs, which is memory management. And specifically in this paper, the authors have proposed a framework which is called as MEMO. And this method, MEMO, is designed to efficiently train a 7 billion parameter LLM on just 8 GPUs, which is a remarkable feat. And along with that, it is also handling extremely long sequence lengths of up to 1 million tokens. So, talking about the motivation behind this work, as LLM size grow in size, their uh, applications span not just in NLP but also in other fields like healthcare, video processing, and more. So these applications often demand a very long context sequence, and training models with such long context is extremely resource intensive, especially in terms of memory consumption. And the self attention mechanism that we all know of, which is used in transformers, is the backbone of these models, and it introduced quadratic complexity both in terms of time as well as space, as well as in memory usage. Additionally, as the sequence length grows, the activations that must be stored for the gradient calculation during the backprop also grows. So this combination essentially puts a significant pressure on the GPU memory, making it very difficult to train these models. And a lot of times we run into memory bottleneck issues. Next slide, please. So this is a diagram which compares the graphs showing the memory consumption as the sequence length increases in the LLMs. And as you can see, the peak A and peak B is where the GPU bottleneck is happening. Right. So there are two commonly used memory reduction techniques which are used while training models. The first one is activation recomputation. Here, instead of storing all the activations during the forward pass, we only store the inputs of certain layers. And these inputs are, later recomputed during the backward pass. So this basically helps in saving memory, but yeah, it does come at a cost of additional computation, which slows down the training. And the second approach is swapping, where activations are offloaded from GPU memory to CPU memory after the forward pass, and during the backward pass, they are reloaded into the GPU. So, while this does reduce the pressure on GPU memory, but this overhead of transmission from the GPU to CPU, can create a bottleneck in the memory. So, both these techniques have these limitations, which Memo is trying to address. Next slide, please. So before we deep dive into Memo, it is important for us to understand the two key types of activations in transformer layers. So first we have skeletal activations. Skeletal activations are the activations which are essentially, very important for backprop, and they must be stored until they are reused for gradient calculations. And without them, we just, cannot compute the gradients that we need to update the model to. And then there are also transient activations. These are just temporary results that are generated during the forward pass or the backward pass, and they are discarded immediately after use. They do not need to be retained or stored for the backprop. Now the challenge with skeletal activations is that they consume a lot of memory, and especially as the sequence length increases, the amount of memory which is required to store these activations increase linearly, which adds to the difficulty of training LLMs. And talking about the issue with the transient activations is that despite of them being transient, they can still consume a significant amount of memory. And another issue is that they contribute to memory fragmentation. Like these activations are created and discarded very frequently. So this creation and discardation creates memory fragmentations. Next slide, please. So before I hand over to my colleague Abhilash, I would just like to ask this question to the audiences: how much memory do you all think approximately would each iteration of computation take? Anyone? Okay, Abhilash, you want to answer for them?
Okay, before I actually answer the question that Sumedh asked, this is a slide which shows up what are the skeletal activations that come up during the computation of a transformer layer. Like Sumedh rightly pointed out, the transient activations need not be stored. These are the activations that are stored and are fetched back during the backward propagation. So to answer Sumit's question, a 32-layer transformer architecture for a 7 billion model would almost take up to 4096 gigabytes of memory in terms of activations. So the strategy with swapping is probably not possible because we don't have 4096 gigabytes of memory. With recomputation, we see that with each sequence, the computation that is going to take up for a sequence of length 1 million is around 128 gigabytes. So even if we follow a 8-degree sequence parallelism, it will still end up with 16 gigabytes per GPU. So we see that both swapping and recomputation have its own problems. Can we go to the next slide, please? Yeah, in the memory allocation, we see that a lot of transient memory is being created and is being destroyed right in the same iteration itself. Because definitely it's not being stored, it's just created for the internal computation graph that PyTorch or any memory allocation does, and then just gotten rid of. But the problem here is the transient memory that is generated is almost equivalent to 5 times the amount of activation memory that comes up. So every time this freeing creation and freeing is happening, it is just freeing out a bigger chunks of blocks in between the memory that was allocated. This totally leads to the memory block problem, wherein like we have total fragmentation, and at the end, when we need the required amount of memory, we don't have the chunk that we require. So it throws up the out of memory exception. Can you go to the next slide? So in this particular work, there are certain degrees of parallelism strategies that they implement. So here is an increasing list of it. We would mostly focus on the sequence parallelism in the paper. So let's jump to the next slide. So here is the slide on memo, the token-wise recomputation and swapping. So basically, the major idea is whatever the time that we spend for the computation, during the computation, if we use that time to save up all the activation memory, that is the skeletal activations, if we can transfer it to CPU, then we are essentially using all the time that went into computation to transfer the extra memory that we are computing here onto CPU, essentially saving memory. So the strategy they use out here is they'll use two different buffers, even numbered buffer, buffer 0, and an odd numbered buffer, buffer 1. And for every transformer layer, like if we are considering the 32-layer architecture for the 7 billion model, the even numbered transformer layer will do its computation and write its output onto the even numbered buffer. After that, the odd numbered transformer layer, when it's doing the computation and writing its memory onto the buffer with its skeletal activations will write all the activations it has onto the memory. So this way, when a computation is happening, parallelly, the previous computation that happened along with its buffer values are written onto the memory. So this way, we are actually saving up time that would take up time in terms of time overhead as well as the computation overhead. But here we also look at two particular constraints that come up. One thing, we can't fully offload the memory that we have. We can't fully offload the skeletal activations that we have because, like I pointed out, it's too much and it goes out of memory space. And at the same time, we can't compute it fully as well because, like I pointed out, again, it takes up around 16 gigabytes per node. That is around 20% of the total memory that we would have. One more thing to consider out here is, I mean, at this point, it's fairly reasonable to assume that the best strategy to go ahead is to split the memory up. But during splitting, we know that the computation and time match, that is the amount of time that the computation is taking up, it should match with the amount of time that we would load the computations onto the memory. So this is one problem where we would focus, that is to find out the percentage of skeletal activations that need to be offloaded onto the memory, and the same activations during the backward propagation, which have to be fetched back from the memory, and the rest of the computation has to be taken care of. So till now, we know that given the total skeletal activations, we split a proportion of it. Can we go to the next slide, please? Yeah, two granularities are exposed. Previous. So one question I would like to ask the audience is, what computation takes the most amount of time in a transformer layer computation? Any answers? You have the answer right on your screen, actually. Okay, I'll answer it. So the most amount of time that is taken up is during the attention calculation. Right now we have the graph for flash attention. So right now we see that around up to when the sequence length exceeds 576K, the amount of time for attention computation is almost equivalent to 90% of the total time that it takes up. So here we understand that the time taken up is so much that we have enough time to load all the all the skeletal activations that are coming up in this layer with respect to attention, with respect to input, key, value pairs. All of this can be written out because we have enough time. Can we go to the next part, please? But once this attention part is done, for the rest of the part, this particular approach does not hold up. So what is happening here is we'll still need to find the proportion. We see that S input, the memory that the input takes up, S attention, the memory that the attention computed matrix that takes up is still fixed. But the rest of the computation that I showed in the previous slides, still has to be split up. How we split up is according to this equation. That is, we take up the total time. The B here is the bandwidth between the CPU and the GPU memory. And T layer is the amount of time a transformer layer would take for the computation. So we see that a proportion alpha has to be found out, which matches the amount of time it takes for a computation. And in that time, it transfers the equivalent amount of data. So the main reason is the time computation complexity is like very less, and we are way ahead in computation. One question I would like to ask the audience again here is, why is the second equation n minus 2 and not n? Well, the answer to this is in the last layers, that is the transformer layer n and n minus 1. We don't need to save it in buffer because the backward propagation is happening immediately after it.
So for bilevel MIP, the bilevel MIP algorithm is the key component of Memo's memory planning strategy. The objective here is that the algorithm basically aims to minimize the peak memory usage while ensuring all the necessary tensors are available when it's needed. In figure 9, it shows the sequence of memory requests during training, illustrating how the different layers request and free memory at different time steps. Since all the transformer layers in a LLM are identical, they have the same forward and the backward pass memory request sequence. Given the memory request sequence, the challenge here lies in determining the address of each requested tensor, while at the same time trying to minimize the peak memory usage.
Hello,
So here we use...
okay, you see the timer, right?
Oh.
So yeah, when you heard that sound, that means the time is over, and then you should stop immediately. Yeah, because we have timer, you can see how much time is left. Okay, any questions? Yeah, this is a very interesting paper. Yeah, maybe we have some questions. If you have questions, you can put it in a chat box. Okay, since we have 4 presentation today, if that's no questions, we move in the chat box. Let's say
Professor,
there is a question.
Yeah, there is a question.
Well, the way this applies to a project is the way they are using the computation mechanism. They're using sequence parallelism. That is something that we would want to take up. And also at the same time, they have the approach of actually splitting up the amount of activation that they would want to store back and then get it back during the backward pass. So we wanted to achieve something similar, but not exactly the same thing. That is to split up the amount of computation that we could save up and then load back at the runtime. So these two approaches is what we would want to take up from the paper. I think that answers your question.
Okay, sounds good. So next group 7. Okay, let's start.
Okay, hi everyone. We're group 7 and we're doing our presentation on the emerging technology AI-driven cooling optimization in data centers. So next slide, please. So what is AI-driven cooling optimization? So we know from class that cooling takes up most of the energy in data centers right now. It can account for up to around 40% of the energy consumption, and the pie chart to the right kind of shows the energy consumption for data centers is from a report back in 2014 before we started going into AI-driven cooling optimization. So AI-driven cooling optimization is just switching to the conventional AC type systems to machine learning based models to optimize real-time cooling decisions in data centers. Next slide. So a little timeline of this technology. So we start having early data centers back in the 1950s, 60s. There's a picture of one from the University of Pennsylvania. And at this point, we're just using regular fans to do the cooling for the servers. And as we jump to the 2000s, we have the rise of the internet and we start getting more large scale data centers, but not at the same caliber that we have now at the warehouse scale. But at this point, by 2010, we already have data centers accounting for 1.3% of global electricity usage. So we already are consuming a lot of electricity back in the 2000s. So we jumped to 2014. Through that time, they're just using regular thermostat, rule-based control systems to do the cooling for data centers, and this is using up a lot of energy. So the first major AI-driven cooling system comes in 2014, and you guys can put in the chat which company you think it is. There's a little hint below of the cooling center at that company. So then after that is developed, and from 2015 to present, this has now become the standard for data centers across the world. So advancements in AI will lead to even more energy efficient tactics, not even just with cooling, but just to lower the energy consumption in data centers. So next. Okay, so how does this work? So in the data centers, they have sensors put all over the different the data center and at specific points, and all the data from the sensors, they take data like temperature, humidity, server load, and they train a model. I know specifically for the answer was Google for the previous slide. Google, they use deep neural networks to do that, but I've seen some papers that use LSTMs, support vector machines, but usually they test a bunch of models and see which one can optimize the cooling. So they train whatever model using this historical sensor data. That model identifies the patterns and correlations between the environmental factors and the server's cooling needs. And then the model continuously processes the incoming data and then monitors the current conditions. And then based from the past data, they will do predictions to prepare for the later environmental conditions. So this is also Google's data center. And some opportunities that you guys might be interested in. So, of course, basically data scientist, data analyst, but you would be more focused on analyzing sensor data and actually developing the machine learning models or improving previous ones to optimize the cooling systems for your company. Or something I found was interesting was energy efficient consulting. So everyone here has a good idea about AI and how it can improve data center efficiency. So there's those two companies, Danfoss and Uptime. I just saw that they had some jobs where you could be consulting companies that have data centers and giving them advice on energy consumption. And then just investing in companies that focus on this, and personal use. There's some recent papers about AI-driven thermostats in houses, maybe eventually, or in even office buildings. So next slide.
Okay. Some of the advantages of using AI for cooling optimization are numerous things. So first, AI can analyze demand and predict what parts of the server needs to be cooled better, and which reduces inefficiency, waste, improving energy efficiency, as well as it could also prevent downtime by predicting maintenance needs. So technicians can fix hardware to ensure smooth operation without disrupting user use. And also, due to constant use of real-time data, AI can maximize energy storage efficiency by predicting future demand surges and troughs to better optimize the cooling apparatuses so that temperatures always stay optimal and prevent waste by ramping up cooling when it is needed. And all this can greatly reduce energy consumption by like 30% in data centers, which also leads to significant cost reductions without having to pay for so much electricity or waste cooling resources. Next slide. So there's a couple of challenges for using AI. So of course, it's the high initial investment. Since AI takes a lot of resources to set up, collecting all the data as well as the hardware, as well as have the hardware self-support using AI, if your data center hardware infrastructure isn't in place, it can take a lot of time, resources, and money to get it set up. As well as AI self-training and using AI can also have large energy usage, which also just offsets any cooling and energy gains you can get from using it in the first place. And can be a risk of over-reliance as AI systems aren't fault-proof and sometimes can behave unpredictably, which might lead to cooling failures or inefficiency and require someone to oversee it. And getting the AI to be trained for this use can be difficult because getting quality data that is needed to train an AI for this can be difficult to find, as you most likely have to get it yourself, and it can be difficult to scale a small model trained for a smaller data center and scale it up to a larger data center. You probably have to retrain it again, as increasing data center size drastically increases the number of variables and metrics that need to be taken account, which can be difficult for to scale up for AI, as you just have to, it'll be significant time investment and money. Next slide. So one of the questions I can ask is that which are the following the potential drawback of AI-driven cooling optimization in data centers? You should put your answer in the chat. I'll just tell you the answer later. Next slide. So some of the alternatives of using AI is, of course, just traditional methods like having someone just optimize based on known historical data or just auditing, using just simple IoT sensors optimization algorithms without needing AI. And of course, using more energy efficient processors and servers such as ARM-based or custom chips like Google's TPU, but these will, of course, more reliant on hardware manufacturers and, of course, require money to update your infrastructure to get it going. So it might not be feasible for everyone. There's also like edge computing, which just gets rid of processing away from data center, reducing energy load and cooling requirement on data centers. Next. So some of the ways AI can be combined with other technologies is, of course, IoT providing sensors, which can provide AI with more up-to-date real-time data on temperature, power usage, and performance, so that it can always be up to date and make more precise adjustments for cooling and energy efficiency. It can also be combined with blockchain. That blockchain technology can be used to more manage energy distribution and AI helps optimize this process, improving overall efficiency. And you can also combine it with renewable energy sources. It could dynamically manage these solar, wind, hydropower by predicting output based on weather patterns and optimize their uses to ensure maximum throughput without wasting any resources. Next. Next.
Yes. So for our application scenarios, we want to look at the industries first. So the industries that are using this, they're mainly going to be the tech industry exclusively. So we have our big players here, Microsoft with their Azure Maya AI Accelerator. and Google with their DeepMind AI for cooling optimization, and also Amazon for their Amazon Web Services all use AI to optimize their cooling in their data centers. And then in terms of future uses, AI-driven cooling solutions and systems will increasingly integrate with smart city frameworks by utilizing geothermal and passive cooling techniques to further reduce reliance on mechanical systems. And future cooling systems in data centers will likely include heat recovery technology by converting waste heat into usable energy. And this diagram shows the potential use of waste heat from a data center by converting the waste heat into heat that can be generated for residential and commercial areas, while also bringing cooling capacity to the data center. And here's a question for the audience. Which of the following advancements in AI algorithms is most likely to significantly enhance efficiency over the next decade? You can put it in the chat. And the answer is B, reinforcement learning. This approach allows systems to learn and adapt dynamically, optimizing cooling in real time. And then accessibility and test results. AI-driven cooling optimization algorithms are not currently open source. And also for the test results, Google's DeepMind achieved a 40% reduction in energy used for cooling in their data centers. And this graph is from their Google's blog that shows the power usage effectiveness being reduced once the machine learning techniques were in place. And also a study was done on AI cooling control algorithms, and it found that it could achieve 11% cooling cost savings using some machine learning methods. And here are our recommended readings, and we're excited. Thank you.
Yeah, good. Perfect timing. Any questions? Yeah, I like the questions you post there. Yeah. I think because for this lecture, I will upload the recording. So for the next quiz, we may ask you a question like the interactive question here. But if you already attend this one and pay attention to the questions, that should be easy for you. Okay, any other questions? This is a question for, I mean, this is a paper presentation, right? I guess your question is more like how this related to your own project.
Yeah, we're not doing our actual project on this specific topic. Overall, we're going for energy efficient cloud computing, but our project that we were talked about on Tuesday is actually working with like different scheduling algorithms. So nothing to do with cooling system, but just simulating like different tasks and then trying to rearrange how they're done to promote energy efficiency. So it's a little different, but kind of under that same umbrella. But yeah.
Yeah, there is a trend that people start to use reinforcement learning or deep reinforcement learning to replace scheduling. So the cooling, as you show, is one example, but there are many more. This is called AI for systems. And similarly, the challenge is also what you list in your second question, right? So it may give unpredictable behavior. And so when things goes wrong, who should be responsible for that? Right? From that perspective, is similar. Okay, for time consideration, let's move on to the next group. Next one is group 6. Anyone from group 6?
Yes, Professor.
Okay, good. You start the timer. Yeah. Go ahead.
Hello everyone, this is Yukma. We are going to talk about trustworthiness in RAG. So today we are looking at how LLMs like ChatGPT can be made smarter when they need extra information. These models are great at understanding and generating text, but they don't know everything. Like if the information is new or very specific. To fix this, we use something called retrieval augmented generation or RAG. This means the model looks up information from outside sources like websites or databases to give better answers. The problem we are trying to solve is that this process is often slow or brings back the wrong information, making the answers less accurate or useful. And so here the question arises, why does this matter? LLMs are increasingly used in real world applications like customer service, answering questions, or even summarizing important information. But they have few major problems when they don't have all the right data. For example, like false information. If the model doesn't know the answer, it sometimes hallucinates and presents false information, which can be harmful or misleading. And what if the question we asked is out of date or generic information? These models rely on what they have been trained on, and if that information is outdated or too general, it can lead to irrelevant responses when users are expecting more specific and current answers. And the other problem may have is sometimes the model pulls from random or non-trusted sources, which can make the information unreliable. And terminology confusion also. If different sources use the same words but mean different things, the model can mix up the meaning, leading to the inaccurate answers. And how can we solve these problems? Here are few ideas. To solve, we need few improvements. First, we need better ways to choose what information the model looks up. If it retrieves only the most relevant documents, the answer will improve. They also talk about how the model can combine the information it retrieves with its own knowledge to create better responses. And finally, we can find a ways to make this process faster so that looking up external data doesn't slow the model down. What are the existing approaches we have? Can you move to the next slide? Thank you. Currently, there are several approaches used to address the challenges of integrating external data into language models, but they still have few limitations like distributed data processing models. These models are designed to handle large amounts of data by processing it in parallel across different systems. They help ensure that as data volume increases, the system can scale efficiently and continue retrieving relevant knowledge. But this approach can still suffer from issues with combining the data seamlessly into the model's generation process. And the other existing approach is fog computing and multi access edge computing. These technologies are used to perform real time data processing closer to the data source, especially in geographical distributed systems. This reduces latency and speeds of retrieval. While this approach works well for the local data, it may not always be effective when dealing with massive or global knowledge bases. And the third one is pre-processing and post-processing techniques. These techniques are used to improve data quality. We know that pre-processing cleans and organizes the data before it's fed into the model, ensuring only useful and accurate information is retrieved. And post processing checks and validates the model's output to catch any errors. So, as we've seen, there are several existing approaches like these. While these approaches have made significant changes, there are still gaps that need to be addressed for more reliable and faster integration of external data into language models. Uh, and we have a little quiz. Uh, so what is the main problem that RAG systems aim to solve in LLMs like ChatGPT? Can anyone answer that question? Yep, I got a lot of answers and the answer is B. Thank you.
Yeah. Okay. Let's move on to the next part. So I will take you to the key points of this project and proposed solution. So we have seen how AI systems like chatbots make up things sometimes which is not right, and they get just assume and hallucinate. That's a very big problem. So, especially when this happens in healthcare or legal services, that might be an issue. So, the solution proposed here is very smart. So, what it does is like it provides a set of resources or external databases so that it could retrieve through them. Instead of relying on what AI thinks it knows, it can actually go out and search and retrieve up to date information from the trusted source. So this is what a RAG does. So it is nothing but an extension of LLM, where it helps in cost effectiveness and improves output accuracy. So there are basically 6 points on which these paper wanted to show their difference. So one is factuality, whether the information is accurate or not. Robustness, like can it handle tricky or unexpected questions. Fairness, like is it treating everyone equally and without bias. Transparency, like can we understand how it got it answer. And accountability, like if it something goes wrong, like can we figure out what exactly has happened. And privacy, like is our data safe when we give all our data to our LLM. So this is what it mostly based upon. And for this, researchers took mainly 3 steps. So first is they have reviewed a bunch of studies to see what has been already done around trustworthiness. And the next thing is they tested existing AI models with free ones and company owned ones and checked how exactly these perform on the 6 areas that I mentioned earlier. And finally, they compared these systems to see which one of the things are right. And they saw that like there is more room to improve in the trustworthiness how they exactly are. And key findings, even though the systems pull from external data, they sometimes give wrong answers, so that says it is not perfect. People trust the AI systems more when they actually see where the information is coming from. Like better if it is provided with a link or document. These systems can still end up biased, especially when the data retrieved is biased from internet or from multiple sources. And privacy is still a concern because there is a risk in protecting this sensitive information. And use case and applications we see these are mainly can be done in used in healthcare, legal services, customer support, education, and finance. So there is a small quiz. Which of the following is not one of the 6 dimensions used to evaluate the trustworthiness of RAG? Can anyone answer this question? Okay, moving forward, Krishna will handle the rest.
Yeah, the challenges. One of the main challenges with the RAG systems is ensuring factual accuracy. When systems retrieve data from external sources, they can still pull
Sorry,
outdated or
I
incorrect
cannot hear you
information.
clearly.
They also struggle with robustness.
Yeah, sorry, the voice
My
is
voice audible, Professor?
yes,
Hello?
yes. Now it's
Yeah.
better.
So another challenge is robustness, meaning they may not perform well in unfamiliar situations or with unexpected inputs. And other is bias. Even unintentionally, these systems can reinforce societal biases present in the data they access. And the other is transparency, where the challenge is the models operate like black boxes, making it hard to trace the decision and also the making process. And the last one is accountability. It's tricky too when errors occur. It's hard to pinpoint who or what is responsible. Can we go to the next slide? So comparison with the existing work, this paper compared to existing research, this paper addresses trustworthiness in RAG systems in a more comprehensive way. Previous studies often focus narrowly on areas like factuality or bias, but this work emphasizes the need to address multiple dimensions, including privacy, accountability, and transparency. It not only highlights current shortcomings, but also provides a structured framework for long-term solutions, integrating ethical considerations into the system design. This survey goes beyond surface level fixes, pushing for deeper system wide improvements to increase real world reliability. So in this future research opportunities are like several promising directions. One area is improving context area retrieval and also investigating AI-driven methods for improved factuality and transparency. And also that there are dynamic updating mechanisms way to ensure RAG systems can access and incorporate the most recent and the reliable data. There's also another need for cross-disciplinary collaboration between technologists and ethics to tackle bias, privacy, and accountability, addressing scalability challenges in large-scale RAG implementations. And if we conclude that the RAG systems hold immense potential, they face significant challenges in ensuring trustworthiness and also addressing issues like factuality, robustness, and bias. Requires both technical innovation and ethical oversight. This paper highlights the need for a multidimensional approach to solve these problems, integrating long-term solutions that balance performance and accountability. Moving forward, future research must bridge the gap between technological advancements and responsible AI used to build systems that ensure a trust. And Professor, these are the references we have took for this paper. And thank you guys for your
Yeah, perfect timing. Any questions you can put in the chat box. For the time consideration, let's start group 10, the last presentation for today. Group 10?
Yes, Professor, we are sharing my screen, quickly sharing my screen. Let me know if my slides are visible.
Yes, that's good.
Yeah. Thank you so much. Yeah. Good morning, everyone. My name is Ashpita. We are from Group 10. Today, we will be discussing regarding one of the recent trending technology in modern artificial intelligence. It's called AI Trism. So we'll quickly go through the introduction. So what is AI Trism? So AI Trism stands for as the name suggests, it stands for AI Trust, Risk, and Security Management. So AI Prism is a framework and practices that organizations uses to manage the trustworthiness, risks, and security concerns related to any AI systems. So what's the use of AI Prism? So due to the rapid adoption of AI systems in various sectors, be it healthcare or finance or anything, the main concern over here is the ethics, security, and biasness in the decisions that are being taken by these AI system. To overcome these challenges, AI Prism framework comes into picture. So this AI Prism addresses the concerns and focuses mainly regarding the risk associated with transparency, explainability, etc. So that's a quick introduction about AI Prism. Now let's go through the milestones in the development of AI Prism. So what's the yearly approach or what's the yearly development of AI Prism? So now if we look into the key milestones, so the concept of AI Prism evolved alongside with the adoption of AI technologies in our everyday's life. So in early 2010s, the AI systems became very popular and there is a need of to regulate the concerns regarding fairness and transparency. So in 2021, a couple of global organizations like OECD and ISO have introduced some standards on how this AI governance should be. So until 2023, there was a proper formal introduction of framework that has been laid by this AI Prism on how those governance of AI principles should look like. And currently in 2024, this AI Prisms becomes a key part in AI developments with industries implementing them in various strategies and decision making. Now, since we have looked into the key milestones, we'll look into the 5 key pillars for AI Prism. So the first one over here is explainability. So as the name suggests, explainability is about making the AI models understandable and transparent. So in AI Prism, this pillars ensures that the AI system provides outputs that can be interpreted by stakeholders, so making those decisions clear and predictable. So the second key pillar here is model ops, which refers to operational side of managing AI models from development to deployment. So it includes automated pipelines, monitoring, and governance that ensures that the AI deployments are maintained properly in production environments in a day-to-day basis. The third one over here is adversarial effect attacks. So this pillar focus on protecting AI systems from any attacks that could alter their behavior. So AI prisms ensure that these models can detect and defend against such threats, which is essential in areas like autonomous driving or financial sector, where small manipulations could have led to harmful outcomes. So the fourth pillar over here is anomaly detection. So what does this anomaly detection mean? So it is critical. It's basically means detecting anomalies. So AI Prism ensures that the issues are addressed before they can be escalated. So if there is any unusual patterns of data or any problem that is being indicated within the data, so these are addressed before they can escalate it to provide, like if they are getting any potential issues. So the final one is data privacy. So data privacy ensures that the user and organizational data is protected. So AI Prisms establish strong privacy controls, ensuring that the sensitive information related to any user or the company is safeguarded and compiled with the regulation standards. So these are the 5 pillars for that laid the foundation for AI Prism. Together, they ensure that the AI systems are not only highly performing but also secure, trustworthy, and reliable. Yeah, since we have gone through the introduction of AI Prism and its key pillars, can you guys answer what's the primary goal for AI Prism? You can answer this in the chat box. So considering the time constraint, I'm just disclosing the answer. So the answer is C. Over to you, Tejashwi.
Yeah, so let's just go through the methodology of how AI Prism works. So AI Prism mostly focuses on the importance of incorporating various technologies and tools to ensure the responsible and ethical use of AI. While this AI Prism doesn't have any specific architecture, depending on the specific needs of an organization, it can be implemented through various strategies and technologies. So some of the approaches include like data governance, model development and testing, risk assessment and management, security measures, and ethical considerations. So by establishing clear policies and procedures for collecting the data, storing and using this data in AI systems, data governance can be achieved. And by rigorous testing and validating AI models to ensure accuracy, fairness, and reliability, risk assessment and management can be done by identifying and accessing potential risks that are associated with AI systems. And security measures can be implemented by robust security measures to protect AI system and the data by from security threats, that is cyber threats, and incorporating ethical principles into development and deployment of AI systems to ensure they are used responsibly and beneficially. So some of the software tools and frameworks are AI Prism utilizes software tools and frameworks to facilitate the risk management. One such of an example is Microsoft Responsible AI Dashboard. So this dashboard is a powerful tool that is designed to help organizations to develop and deploy AI systems in a very responsible and ethical manner. It provides a centralized platform for accessing, monitoring, and mitigating potential biases, risk, and ethical concerns that are associated with the models. So, by using the responsible AI dashboard, organizations can enhance model fairness by identifying and addressing biases to ensure and give equal outcomes. They can improve the model transparency, like explain how the models reach their conclusions to increase their trust, mitigate risks by detecting and addressing the potential risks that are associated, and by demonstrating compliance, that is, comply with regulations, adherence to ethical AI principles and regulations. Next slide. So let's go over some of the opportunities we have. So there are many opportunities for us, like there will be a growing demand for AI of ethics officers, risk managers, and AI auditors. New job roles focusing on AI governance, fairness, and compliance will be increased. There will be a need for data scientists to focus on creating transparent and unbiased models, privacy in AI assistants, etc. And also in investment opportunities, like in startups focusing on AI security, transparency, and ethical AI solutions. And now let's go over some pros and cons of AI Prism. So the first one is transparency and accountability, security and privacy, compliance with regulation, trustworthiness. So AI Prism helps ensure that AI systems are transparent by making the models understandable and auditable so that stakeholders can trust the decisions that are made are transparent, fair, and ethical. And bias detection and mitigation, it integrates tools to detect and correct biases in AI systems. That decisions made by the models are fair and non-discriminatory across different user groups. Trustworthiness, the framework focuses on ensuring AI model that it is not only effective but it is also reliable and trustworthy. This is very essential for industries relying on accurate predictions for fair outcomes like finance or healthcare. Let's go over some cons of AI Prism. Performance trade-off. That is, there is often a trade-off between transparency and model complexity. That is, the framework may limit use of complex black box models like deep learning networks and all. And implementation complexity, like adding more layers of trust, risk, and security may require significant changes to existing workflows. The cost of maintenance and monitoring will be high due to these layers, and there will also be a possible delay in deployment because of the robust testing, and there will be a limited flexibility also. So these are the pros and cons. Now let's go over one MCQ. What is a potential drawback of using AI Prism in fast-paced industries? You can answer this in the chat box. Yeah, over to you, Gunjan.
Yes, I hope I'm audible. Talking about the application scenarios for AI Prism, starting with the healthcare. So many companies in healthcare like IBM Watson or Google Health, they rely on the AI models for predictive analysis and for disease diagnosis. So here the AI Prism ensures that these models are transparent, ethical, and it also makes sure the safeguarding of patients' data privacy and also make sure that the data is preventing from any such misuses. Coming to the financial institutions, so many financial institutions like JP Morgan, Goldman Sachs, Citibanks, it uses AI for tasks like credit scoring, loan approval, or fraud detection. So AI Prism here ensures that these AI-driven processes comply with the financial regulations such as for the Fair Lending Act, which provides transparency to regulators and it ensures the ethical use of the customer data. Next slide. Talking about the future trends in AI tourism, increased regulation. So governments will enforce AI-specific regulations, ensuring ethical practices. AI tourism will drive responsible compliance. Automated AI governance. So here AI will self-regulate by autonomously detecting and resolving biasness, risks, and compliances issues, ensuring governance. AI security innovation. So here AI cybersecurity advancements will improve defenses against the adversarial attacks, integrating AI tourism for stronger threat reliance. Next. Case studies and industry test results. So talking about the healthcare, in healthcare, predictive models are often used to assist in diagnosing conditions, determining the patient risk factor, or for evaluating patients' eligibility for specific treatments, such as for critical care. So these models typically rely on the historical data that can contain biasness, such as for underrepresentation of certain demographic groups like racial minorities or economically disadvantaged individual. So such biasness can lead to unfair treatment. Thank you so much.
Yeah. Thank you. Given the time, we already go over time, so we will stop here and we will continue next Tuesday. Yeah. Thank you, guys.